Bismillahirrahmanirrahim. Today I'd like to talk about the relationship between areas of similar figures. So if two figures are related, then all their sides will have the same proportion. If you recall, if two figures are similar, then two conditions must apply. All their corresponding angles are congruent, and all their corresponding sides are proportional. For example, before you here, you see two similar right triangles. The second triangle is simply a multiple of the first one. Every side is multiplied by 2. So the ratio of the sides here is 1 to 2. So if the ratio of the sides is A over B, we notice that the ratio of the areas of similar figures will be also related. So if the ratio of the sides is A over B, we will observe that the ratio of the areas will be A squared over B squared. So if the ratio of sides of a triangle or any other similar figure is A to B, then the ratio of the areas of those two similar figures, whether they be triangles or anything else, the ratio of their areas would be A squared over B squared. And if you were dealing with solid figures or three-dimensional figures, we will notice that the ratio of their volumes will also be related, and it would be A cubed over B cubed. So in this case, we know that the ratio of the first triangle over here to the second triangle, let's label this triangle as triangle 1, as triangle 2. We know that the ratio of the sides of the first two triangles, triangle 1 over triangle B, the ratio is 3 over 6, which is 1 over 2. So this is the ratio of their sides. Then we could predict, in fact, that the ratio of their areas, that the area of the first triangle to the area of the second triangle, would be A squared over B squared. In this case, it would be 1 squared over 2 squared, or 1 over 4. So let's see. Let's find the area of the first triangle over here. Area, of course, is 1/2 base times height of the triangle. It would be 1/2 times 4 times 3. For the area of the first triangle is 6. And if we were to find the area of the second triangle, let me just label it like this. It's 1/2 the base times height, and that simplifies to 24. Now let's compare the area of the two triangles. So the area of the first triangle, like this, triangle area, to the second triangle area, is going to be 6 over 24, and indeed, this simplifies to 6 goes into 24 4 times, 1 over 4. So indeed, we have demonstrated here in this example that if the two sides of similar figures are related as A over B, then their areas will be squares like this, A squared over B squared. Okay, so I would just like to elaborate on this before we move on. So if you have two figures, not just any two figures, but two similar figures, then we would notice that their sides, perimeters, areas, and if they were three-dimensional figures, their volumes would be related. For two figures to be similar, their sides have to be proportional. And if their sides are proportional with the ratio of A over B, we have realized that their areas are also proportional, but the proportionality is A squared over B squared. We have learned previously that if two figures are similar, then the perimeters are also proportional. And the perimeter ratio is the same as the ratio of the sides, that's A over B. And their volumes will also be proportional if it's a three-dimensional figures to A cubed over B cubed. So let's do some problems keeping this in mind. Okay, so we have a question before us. It says, what is the ratio of the perimeters and areas? So we're asked two questions here, the ratio of perimeters and the ratio of areas of two similar figures if the sides are in a ratio of 2 to 5. So if the sides in a ratio of 2 to 5, that is A over B, is 2 to 5, then the ratio of the perimeters will be the same. Their perimeters will be also in the same ratio, 2 to 5. And then the ratio of their areas, the area of the first figure to the area of the second figure, would be A squared over B squared. In this case, it would be 2 squared over 5 squared, 4 over 25. So if two figures are similar and the ratio of their size is 2 to 5, then the ratio of their perimeters will be the same, and the ratio of their areas would be 4 to 25. Now we have a follow-up question. We asked, what is the area of the second figure if the area of the first figure is 12? Okay, so we know that the ratio of the sides is 2 to 5. And therefore, we have concluded over here that the ratio of their areas will be a squared over b squared, or 4 over 25. So if that's the ratio of their areas, what would be the area of the second figure if the area of the first figure is 12? So we just set up a proportionality like this. The ratio of the areas will be 4 over 5. And if the first area is 12, what would be the area of the second figure, like this? So we set up a proportionality, and then we solve for x. We solve this by cross multiplication. So you would have 4x is equal to 12 times 25. And you can divide both sides by 4 like this. And you simplify, you get x is equal to 75. So the area of the second figure will be 75. Okay, so let's do another example. Here we're given two hexagons and we're given some information. They're similar hexagons and the side ratio is 12 to 33. And we're asked to find the missing information. P here stands for perimeter. We're told that the perimeter here is 60. And we're asked to find the perimeter of the second hexagon. And we're given the area of the second hexagon and we're asked to find the area of the first hexagon. Okay, we know these are similar hexagons and their sides are therefore proportional, A over B. And we're told that the proportionality is 12 to 33 like this. So if that's the ratio of the sides, we recognize that's the same ratio as the perimeter. If the perimeter of the first one is 60, then we can find the perimeter of the second one like this by setting up a proportionality. Now you can cross multiply over here. You would get 12 times x is equal to 60 times 33. And you multiply that and then you divide both sides by 12 like this. And then you would get x is equal to 165, I believe. So there it is. So the perimeter of the second hexagon here would be 165. Excellent. So we got that. Now we're asked to find the area of the first one if you're given the area of the second one. Well, we know that the areas will be related like this. The ratios of the areas will be 12 squared over 33 squared. It won't be 12 over 33, but the ratio of the areas will be a squared over b squared. And we're given that the area of the second one here is 484. And then we're asked to find the area of the first one like this. Now here you can cross multiply. You have 33 squared times y is equal to 12 squared times 484. You can do the math as you go along, but I sometimes just do it all in the end. So you divide both sides by 33 squared. You have 12 squared times 484 divided by 33 squared. And if you simplify this, you get y to be 64. So in summary, today we learned the relationship between areas of similar figures. Two figures are similar, their proportionality is a over b, then their perimeters are similarly proportional, a over b. But their areas will be proportional to the squares, a squared over b squared. And if they were three-dimensional figures such as cubes, then their volumes will be proportional to a cubed over b cubed. So if you know the proportionality of the sides, you know a lot about the perimeters, areas, and the volumes. I hope you enjoy this. Until next time, as-salatu was-salamu ala rasulillah, walhamdulillah rabbil alameen. Assalamu alaikum.